This video is part 2 of rationalizing the denominator. So in the last video we looked at questions where there's a single term at the bottom there's a single term in your denominator. So let's just get that colour out here. Nice. There you can see that's just 2 root 3. That's a single term. In this video we're stepping it up just another level, and this is the hardest I think it's going to get, and that's where we have 2 terms. So you can see here in the denominator here we've got 2 terms. Now in the last video, when we had a single term in the denominator, say 4 root 5, to rationalize that we multiplied by root 5 because we could see the root 5s would become 5 when you multiply them. So the question now is, what do I multiply my denominator by here? So I have a method. I know I've got to multiply the numerator and denominator by the same expression, but what would that expression be? Well, in our last video, I'm hoping you may have noticed that whenever you have a difference of 2 squares containing surds, so for example, let's try 3 minus root 5 and let's multiply by 3 plus root 5. That's a difference of 2 squares because you've got the same exact terms. Sorry, my writing's all over the place. You've got the same exact terms in your brackets, but there's in the first bracket there's a minus, in the second bracket there's a plus. If I was to do expand this difference of 2 squares, it would be 3 squared, which is the first term squared, minus the second term squared, and that would give me 9 minus 5, which gives me 4. When you have a difference of 2 squares expansion involving surds, you will find you always end up with an integer. And so that is the key to rationalizing a denominator. When you have more than when you have 2 terms in the denominator, what you want to do is create the other half of that difference of 2 squares. So if this says 1 plus root 2, then the other half of the difference of 2 squares would be 1 minus root 2. And if you're going to multiply the denominator by 1 minus root 2, you need to also multiply the top by 1 minus root 2 so that you're really not changing the size of this expression, because really you're just multiplying by this, which is 1. Multiplying anything by 1 will keep it exactly as it is. So now that we've got a difference of 2 squares on the bottom, the easy way to expand that expansion would be first term squared minus the second term squared. Now hopefully some of you are getting better at doing that in your head. You don't have to write 1 squared minus root 2 squared. If you can see that that's 1 minus 2, that's fantastic. And then on the top we're going to have root 2 outside of 1 minus root 2. Now in our next line we're going to tidy. So when we tidy, we're going to expand the numerator, expand the brackets in the numerator, and then we're going to tidy up the bottom as well. So let's do that. So we've got on the denominator 1 minus 2, that's nice and easy, and in the numerator root 2 times 1, well that's root 2, and root 2 times root 2, well that would be 2. And then a little bit more tidying, I can tidy up the denominator to make it minus 1. Now here's the point where I think most students might leave the question in a way that we would consider to be unsimplified. The best thing to do at this point, I might keep going up here, is that minus in the denominator, we don't really like the minus to be left there. You can, however, bring it to the numerator, but when you bring it up to the numerator, you need to make sure you understand that it actually affects both the terms in the numerator, which is why I've written it with brackets. So you can't just drag that minus up there and write minus root 2 minus 2 like this. That actually would be incorrect. When you drag the minus up to the numerator, it actually affects everything in the numerator. So you can write it like that, and actually my preference would be that you expand the minus through the bracket. So a negative, that's really a negative 1 times by root 2 is negative root 2, and negative 1 times by negative 2 would give you positive 2. That would probably be my preferred final answer, or 2 minus root 2. Either of those lines is perfectly fine. So that's definitely harder than the questions in the previous one, so we'll have a look at 2 more. They do require a bit of work. So as a reminder, when we're rationalizing and there are 2 terms in the denominator, we're trying to create a difference of 2 squares in the denominator. So I've got half of the difference of 2 squares now. The other half would be root 2 minus root 5. And because whatever I do to the denominator, I must also do to the numerator, I'm going to write it in the numerator as well. When we expand now, we can say, well, root 2 squared, well, that's 2, and 5 squared, that's 25. So I'm definitely getting more efficient with my expanding. Now this question's harder than the last one because what I have here is a binomial expansion. And if you know your expansions well, you'll see that that's a perfect square. So really it would be root 2 minus 5 all squared. Now you are expected to expand that, so if I expand that out, it would be first term squared, which is 2. These two terms multiplied together and doubled, well, that would be minus 5 root 2, and if I double it, I get minus 10 root 2. So if you're having trouble understanding that, I multiply the 5 and the root 2 first, and that gives me minus 5 root 2, and then I can take my minus 5 root 2, and don't forget you have to double that. And when you double it, really you're multiplying this 5 over here by 2, which gives you minus 10 root 2. I hope that makes sense. And in the denominator, you've got 2 minus 25, well, that's minus 23. Okay. Now, as we said before, we don't really want to leave a negative in the denominator, so I would recommend that you bring that minus up to the numerator. It will affect both terms in the numerator, so I'll write it like this. The denominator now is just over 23, and the best way I think to leave your answer would be to expand that minus through. So a negative 1 times 2 would be negative 2, and negative 1 times minus 10 root 2 would give you positive 10 root 2 all over 23 would be my preferred final answer for that question. All right, we're nearly there. One more to go. We are going to expand. What I would recommend is, if you're feeling pretty confident, I would do this question without me. It looks quite full on with all those surds, so just go slowly and pause the video, give it a go, and then unpause it to see if we have the same answer as each other. For those of you who are finding it hard, let's move on together. So we're going to multiply and create the other half of the difference 2 squares. So if it's 3 root 3 minus 2 root 2, I'm going to write 3 root 3 plus 2 root 2. And whatever I have in the denominator, I'll also need in the numerator. And now I've got quite a lot of expanding to do. Now the denominator is a difference of 2 squares. So we're going to square the first term. So that would be 9 times 3. So I'm just going to write that square down there. And here I'm going to square this. That would be 4 because I square the 2. And I square the root 2 gives me 2. In the numerator, I have a long binomial expansion. So for those of you who find this hard, you can write it out like that so that you can expand it in the next line. Some of you may not need to. Let's expand it. We've got 4 times 3 root 3, that's 12 root 3. And 4 times 2 root 2, that gives me 8 root 2. We've got minus root 3 times 3 root 3. That'll give me minus 9. That one's tricky because the root 3's, let me highlight them, these root 3's become 3. Then you times that 3 by 3, you get 9, and then you've got a minus here. So altogether we get minus 9. And then finally, minus root 3 times 2 root 2. So we're going to have, well, the negative term will make this overall a negative. There's only one integer at the front of the surd, so that's 2, and then I'll multiply the surd, so root 3 by root 2, gives you root 6. All over. 27 minus 8, that's not so bad, that's 19, 27 minus 8. So really, I probably need a bit more space up here. If you look at the numerator, we have not a single like surd. There's a root 3, there's a root 2, and there's a root 6, and then this has no surd part. So what I'm going to do is just keep the numerator exactly as it is. So 12 root 3 plus 8 root 2 minus 9 minus 2 root 6, and it's going to all be over 19. So not the loveliest of questions, all the surds didn't simplify nicely or collect together, but you can expect that. You need to be able to handle that kind of multiplication. All right, that's the end of rationalising the denominator, part 2.